In lesson 72, we look at lines from experimental data and negative angles. On the first example, this is where you have to draw your own line now. They used to give that to you, but now when you see these points that are plotted for you from data, you have to draw the line yourself and then find your slope and y-intercept. So what I'm going to do is use this line function to help draw the line, but you can see that the line should be positive or have a positive slope. So everybody's is going to be a little bit different here. But I'm going to try to pick a couple of good points on my line. So even if these are different, all the lines that we draw, they should have positive slopes. That should be the same. Okay, so I picked a couple points and drawn a triangle here to find out what my slope is. Now these are going, let's see, 1, 2, so these are by 1, so 1, 2, 3, 4, 5, 6 for my rise. And then for the run, this is going by 20s each. So 1, 2, 3, 4. That would be 80 here. So 80 on the bottom. And then I'll have to reduce that. So I'll reduce that to 3 over 40. Then I'll put that in for my slope. So I have now S equals 3 over 40 C plus B. Now I pick out a point, and I'll just use this 41 and put that in for, let's see, instead of X and Y now it is C and S in this. So I put in 340 times 40 plus B equals 1. So this is just 3, that's pretty nice. And subtract the 3. So B equals -2. So now I have S equals 3/40, that is a 4, C -2. Okay, and then that's going to be the equation of my line for this data set. And yours might be a little different, but as long as you have a positive slope and a similar y-intercept that would be in the negative range here, I would count that correct. Now later on you'll get into linear regression and be able to use either a calculator or a spreadsheet, and different spreadsheets would work, not just Excel, but there are different spreadsheets you could use to find linear regression that's a little bit more accurate than just drawing it and putting in 2 points. Alright, the next thing we're looking at here is writing this polar coordinate for at a measure of -210 degrees and changing that to rectangular coordinates. So we haven't had these negative angles, but they do work the same, and you can just put that in with the negative angle to find your R and U. But it is good to know what angle is related, because later on we're going to look for I want to say perfect answers, or answers where you leave like a square root of 2, square root of 3 in your coordinates. And to be accurate with that, you'll need to be able to find 30, 60, and 45 degree angles that would be related to the angles they give us. So if we started from the x-axis here and then we went down instead of up. We normally go counterclockwise. This time we would go clockwise, and that would be the negative. And see, if we go from here to here, that's negative 90 degrees, and then from there to the x-axis again, that's a negative 180 degrees. And then we still have a negative 30 to go. So 30 degrees is actually the relative angle here. Okay, so you could use 30 here, but you would have to watch and make sure that you got your signs correct. So since this is in the second quadrant, we know this is going to be a negative, positive. So R will be negative and U will be positive. Alright, on this first section, for cosine of negative 210 degrees, that gives us negative 3.46, and that would be R. And then on the second one, that will give us, let's see, 4 sine of negative 210 is 2, so plus 2u. Now you can also write this with the square root, and that would be fine also. But until we get to that point, I'll go ahead and keep that in decimal form. If this is what we're looking for, and we've been switching from polar to rectangular, just now we're going to have some negative angles to work with. And we'll need to learn how they work and what their relative angles are.